Welcome back to NEXTED by Nexaspaces. In this module, we'll dive into the world of sensors, actuators, and data acquisition. Sensors are the eyes, ears, and touch of embedded systems, allowing devices to sense changes in the environment. Actuators are the muscles, enabling systems to act and control the physical world. And data acquisition ties it all together, helping us record and process valuable information. From temperature and humidity sensors to motor control and data logging. This module will help you understand how embedded systems truly interact with the real world. Let's start with sensors. A temperature sensor, like the LM35 or DS18B20, converts heat into an electrical signal. A humidity sensor, like the DHT11 or DHT22, measures moisture in the air. And a motion sensor, such as a PIR sensor, detects infrared radiation emitted by moving objects. To interface these with a microcontroller, we use digital or analog pins. The microcontroller reads the signal and translates it into meaningful values, such as degrees Celsius, relative humidity, or motion detection. In IoT applications, these sensors enable powerful solutions: smart homes adjusting air conditioning, farms monitoring climate for crops, or security systems detecting intruders. Reading sensor data in real time is critical for embedded applications. Using microcontrollers, we can continuously pull sensor values and display them on serial monitors, LCDs, or even send them to a mobile app via Wi-Fi or Bluetooth. For example, a smart home thermostat doesn't just measure temperature once a day, it monitors it constantly, adjusting in real time. Similarly, an industrial machine monitors vibration and heat in real time to predict failures before they occur. Real-time data acquisition ensures systems respond instantly, creating safety, efficiency, and intelligence. Now, let's move from sensing to action. Actuators are devices that convert electrical signals into physical action. A relay allows us to control high-power appliances like fans and lights with a low-power microcontroller. Motors enable movement: DC motors for simple rotation, stepper motors for precision, and servo motors for controlled angles. LEDs are the simplest actuators, providing visual feedback or lighting. When combined with sensors, actuators create smart systems. For example, motion detected by a PIR sensor can trigger a relay to switch on lights. Temperature readings can control a fan motor. Humidity levels can activate water pumps in agriculture. Collecting sensor data is useful, but storing it is even more powerful. This process is called data logging. Microcontrollers can log data into SD cards, EEPROM memory, or send it to cloud servers for analysis. For instance, a weather station records temperature and humidity data every minute, building a dataset for predicting future conditions. Data logging enables performance tracking, fault diagnosis, and predictive maintenance. It transforms raw sensor readings into valuable insights for industries, healthcare, and smart cities. Most real-world signals, like temperature, sound, or light, are analog. But microcontrollers understand only digital signals. That's why we need ADC, analog to digital converters. An ADC takes analog input, like voltage from a temperature sensor, and converts it into a digital number that the microcontroller can process. For example, a 10-bit ADC divides an input range into 1024 steps for precision. On the other side, DAC, digital to analog converters, do the reverse. They take digital signals and convert them into smooth analog signals, useful for generating audio, controlling motor speeds, or dimming lights. Together, ADC and DAC are the translators between the real world and the digital brain of embedded systems. In this module, we introduced the fascinating world of sensors, actuators, and data acquisition. From reading temperature, humidity, and motion sensors, to controlling motors, relays, and LEDs, you now see how embedded systems interact with the real world. We also highlighted the importance of real-time monitoring, data logging, and the role of ADC and DAC in bridging analog and digital domains. In the upcoming videos, we'll cover each of these topics in detail with practical examples and demonstrations, so you can not only understand the theory but also apply it in real-world projects. Stay tuned with NEXTED by Nexaspaces.